Okay, good afternoon, ladies and gentlemen. I'm so lucky that I'm the last speaker today. And I think we have a lot of interesting presentation today that I don't need to spend time to tell you how attractive the IoT is, how big the market, because a lot of people following up a lot of interesting number around, right? And we also have a lot of sharings, right, from all the previous speakers about the opportunities, right, about the possibilities of the IoT. So for me, right, today I'm representing the Texas Instruments to present you the solutions to implement all these kind of possibility and opportunities, right, in a very low level hardware. Okay. So the conclusion for the meeting today, I believe, is IoT impact all segments, right? From the home, smart home, to the industrial, say the industrial 4.0, or the fitness, healthcare, automotive. I think today all the speakers cover all this area already. So I'm so lucky that I hit the jackpot, right? And my presentation will address all this area. So first of all, right, IoT is a united relation of connectivities. So throughout all the presentation, you will hear about several key things: sensor, connectivities, and the cloud, right? Then the data analysis. And my presentation today will focus on the first two areas, the sensing and the connectivities. So let me start with the connectivity first. And today you may hear a lot of a buzzword on the connectivity, right? The ZigBee, Wi-Fi, BLE, right? 6LoWPAN or whatever, right? Even lower, a lot of different standards in the market. That means, right, one size doesn't fit all. There's a lot of a demand in different areas that you need to tackle. Right. So the solution from Texas Instruments is we would like to provide a broad variety of wired and wireless communications. For example, right, in Texas Instruments, we provide the solution on ZigBee, right, which is widely used in a lot of industrial applications for the sensor connect. We also have sub-1 GHz. This is also another popular connectivity topologies, right, in long range connectivities. And again, right, BLE is very popular. But today, hottest topic is BLE, right, which is linked to Wi-Fi. Right, last time, people all talking about Wi-Fi, but you know the Wi-Fi have some bottleneck or the power consumptions. Right? Today's speaker saying that, oh, size is important, as well as power consumption. So we have to trace the balance between Wi-Fi and BLE. And again, right, power line communications and infrared, they are also a means of communications. Beside the wireless, we also the wider communication. So in short, there's a lot of different communication in the market. And TI have the solutions to adjust this. First of all, right, I can say that only TI has all the IoT building blocks in the markets. Where, for example, in the nodes area, in the sensor nodes, we have the MCU, we have the connectivities, we also have connectivity with built-in MCUs, we have power management, we have the analog signal chain, and sensors. Right, these are all the key elements in the sensor node. And then in the gateway or the router, right, again, we have a high-performance MCU, processor, wireless connectivities area, as well in the car. Right, we have all the multi-core processor, our Citara family, right, the signal chain and the power management. So in general, we have the entire solution in the entire IoT ecosystem. Now, of course, I'm not going to tell you all this today. I only have limited time. So in the coming 20 minutes, right, I will focus on the two areas, connectivities and sensor. So start with the connectivities. As I mentioned that there is a different requirement, different standard in the market. So instead of building a special parks focusing on the ZigBee or focus on the Wi-Fi, then you may take a lot of time to learn different devices. So the latest technology from TI is we are building the first multi-standard wireless MCU platform for the IoT. So in this platform, we can support 5 technologies in one architecture. So instead of learning each technology every time, now you only need to learn one time. Then you could apply it to, for example, for the Bluetooth, 6LoWPAN, ZigBee, sub-1 GHz, or RFID. which is highly used in the IoT area for the sensor applications. The key thing is the entire architecture, they are all the same. The only difference is on the RF side. And frankly speaking, RF is not easy to deal with. So for TI, we have a dedicated RF core. We have a dedicated level processor based on the Cortex M0 to do the RF things. So you don't need to touch on the RF, right? So what you do is consider this as kind of a MCU with the RF connectivities. You can spend your time, your effort on building on your own apps. You don't need to concern about how the RF is done, right? You don't need to worry about the Bluetooth connectivity, low signal, 6-4-pin connectivities. You just work on your apps. How to implement your ideas, right, with the IoT, right? For example, like the brainwave, right, or this thing, right? You can focus on your algorithm. You don't need to spend your time to study all the complicated RF stuff. At the same time, right, you could choose between different RF technology with the same design by just switching the chip. Right? This is an example that we have different chips, right, focusing on different areas. For example, the CC2650, this is a 2.4 gig multi-standard platform. The same chip can be used for BLE, for CB, right, RF for CE. We also have a dedicated chip just for the Bluetooth Smart, or the dedicated chip for the 6-low-pan. In general, the hardware is the same. Right? Another major breakthrough is, in the olden day, most of the time the embedded MCU have to do all the things. When I say all the things, that means including the RF stack. In our new design, we have a dedicated processor, the M0, focusing on the RF stack, that won't compete with you on the CPU power. So you have your own. In this case, we are using the ARM Cortex M3 as a processor core. That provides you the best performance with the lowest power consumption. And another very special arrangement is we also have a sensor controller. Today we are talking about sensor. Right? A lot of the event being triggered by the sensor. So in the older design, you have to turn on the entire MCU to monitor all the things. That means power consumption. So in order to reduce the power consumptions, right, you could have the MCU go to sleep mode and have this special sensor controller to monitor all the sensor activities. You could set the threshold through a very simple graphic user interface. Right? When that signal exceeds a certain level, it will trigger the event, right? Wake up the system. Have this the sensor controller to do the processing, or wake up the main CPU to do further processing. After you do all the processing, you could wake up the RF to transmit the signal up. In this case, you have the best power utilizations. And again, right, the difference of all these four is only on the RF one. For the rest of the items, they are the same. Package is the same. So you only have to learn once. Then you could apply your idea into different topologies of RF communications. That will help you significantly reduce your development cycle. Right? We have customers can build an entire system from scratch to production in 3 months because they don't need to learn about all the complicated RF. They're just focusing on the applications developments. Very simple to use and very easy to migrate between different platforms. So here, give you more details about our portfolios, right? Like for this one, this is the BLE platform. I already mentioned to you this M3 platform, but we also have traditional platform based on the 8051. But this is still a very acceptable platform in the market. A lot of customers are still buying this one. But the M3 is the latest solutions. And again, Wi-Fi, right? In Wi-Fi, we need more processing power, so we are using the M4 core, right? That gives you higher processing power. We have two versions. One version, the CC3200 with the M4 core. The CC31000 without the MCU core just give you the wireless connectivities. Right, so it depends on your application. If your main processor already have the processing power, right, then you could use your main processor. Or you could even eliminate the external processor and use the embedded M4 to do the processing. And again, sub-1 giga, right? This is hot in the market in the industrial application, in the smart city, in the building automations. Because what you need here is long range, right? Long distance support. for example, through the wall in the entire buildings, right? The theoretical distance could be up to, say, 25 kilometers. And we have experiments that with a good condition, we could transmit over 100 kilometers, right, with the sub-giga families. So in the sub-giga area, we are also supporting not only the point-to-point, we can also support the star network or the mesh network through the adoption of, say, signal pen, ZigBee, this kind of different RF interface. So we also have a solution called a Y-Link. Right. This is a solution that based on a multiple frequency for you to link up the wireless, for example, the Bluetooth and the Wi-Fi together, for example, in the automotive, right, where you may have Wi-Fi, Bluetooth, right, in the same areas, that this is a very good solution, right, for you as educators to connect the Wi-Fi device and the Bluetooth device. We could also support the 2.4 and the 5 gig support as well. And we have different versions where we all even have modules, right, that could help you to simplify your design. So this is the summary of our wireless topologies. We have the Bluetooth, we have the Wi-Fi, and we have the sub 1 gig. So they all build on a similar architecture to simplify your design. So now you only have to learn once. And TI provide you all the development platform, like the real-time OS, where you could also upgrade your OS on the air. So this finished my part 1 of the presentations. So part 2, sensor. This is more interesting. In TI, we have sensor and also the analog front end, the sensor analog front end. In the sensor area, we have temperature and humidity sensor. In fact, today I hear a lot of presenter talking about temperature, humidity, this kind of sensing, and TI have the solutions. We also have the ambient light sensor and the Hall sensor. In the analog front end side, we have inductive sensing. This is a more interesting area. I don't know if you heard about the inductive sensing a lot, right? Later on, I will give you more details. And we also have the cap sensing, ultrasonic sensing, heart rate monitoring, as well as gas sensing analog front end solutions that address today's IoT market. In the smart home, smart city, factory automations, these kind of areas. So first one is the humidity sensor. This is a very, very compact sensor that composed of the temperature and the humidity in one chip. And the TI's breakthrough is we give you a very high accuracy of the humidity readings. For example, in these models, the 1080, we give you 2% accuracy on the relative humidity up to 85 degrees Celsius. This is an industrial temperature range. Most of the devices available in the market only up to 60, and we can up to 85. That could be used in the factory automations, right? Give you a very precise reading of both the humidity and the temperature. You see the temperature accuracy only 0.2. Output is I²C. So you don't need to worry about how to set, just read it, right? Use a microcontroller like I²C, but just to read the data out. Simple to use. You don't need to learn anything, right? Because it's direct reading. And we also have temp sensor, right? We have an analog temp sensor. In fact, TI have the widest range of temp sensor in the market, right, from the analog to digital. Over here, I have 2 examples. One is the low-cost temp sensor. Today, a lot of customers still using thermistor, right? Thermistor is easy to use, low cost, right? But at the same time, it is quite power-consuming because thermistor level alone. You also have to add the op-amp, a lot of extra circuitry, right? So you need to do a tuning. They are not the linear. And for the IC temp sensor, you see the output is linear. You don't need to do the table lookup. You don't need to do extra op-amp in the temp sensor interface. Simple. And the most important thing, very low power. Take a look, right? Only around 5 microamp only. Or in some applications where you want to have high accuracy, for example, body temperature or room temperature, you need a very high accuracy. We have the high precision temp sensor, the accuracy down to 0.1 degrees C accuracy. Very high accuracy could be used, right, in the wearable device to measure your skin temperature, or could be used in the ventilation area to measure the room-to-room temperature, right? So if you don't like analog, we also have digitals, right? Digital temp sensor, there's a lot in the market. For example, I²C, SPI. I'm not talking about that one because it's very traditional. The latest solution from TI, they are also including a very simple digital interface. For example, using a UART, you could cascade, right, 32 sensors in one string. Right, that will be very easy for you to do the interface. For example, in factory automations, right, you may have a production line. You want to measure different points temperature. Right, last time, every temp sensor is one I/O port to you. And now, you could using only one UART output, connect up to 32 sensors. And each sensor could be 3 meters apart. So you could see long distance, long range, or in a cargo container, right? Or if your system running out of I/O, or you have a problem on the power consumption, we also have digital temp sensor, only have 2 pins. We don't even need to power it. We're using the GPIO to read it. Very simple to use, right? All these are direct readings. Or you want to have a non-contact type temp sensor, we have this kind of a non-contact type thermal sensor. You don't need to touch the body, right? Then you could do a very accurate temperature measurement. Or in some area, you want to measure very high temperature, you don't want to touch it, right? We have this kind of a non-contact type sensor. And light sensor, right? This is a new device from TI. We now got a very good adoption in the home automations. Today, right, you see all this kind of lighting. Last time when we want to do the light, the lumen test, is quite easy because 20 years ago we only have the incandescent lamp or fluorescent tube. But today the lighting are complex. We have solid-state lighting. We have different kinds of lighting in the room. Different lighting, in fact, their spectrum is different. If you're still using the old technology like the CDS, the photoresistor, photodiode, you may have problem because all these kind of lighting, they have different spectrum. For example, IR, you don't want to measure the IR, right? So this is the latest solution from TI that they are almost 99% resemble the human eye. We have 99% rejection on the IR. So we're only focusing on the visible light. And again, with a very good linearity, right, from 0.01 lux to 85 VK, very linear. At the same time, we are also linear to different light source, so you don't need to do calibrations. This is important for a smart home, for the mood control, for the lighting control. Simple to use because the output, again, I2C. Very simple digital output, you just read it, right? The sensor itself, the size is very small, only 2.2. That solves you the size problem as well. And on the heart rate monitoring and the pulse oximeter, we also have solution to adjust that. For example, right, by now a lot of wearable devices, they have the heart rate monitoring. Right? This is a solution from TI. For example, like this watch, right, they are also embedded with TI solutions in there. And in fact, in Science Park, we also have a lot of customers using our park to building this kind of heart rate monitoring in a wearable device. Right? The key is low power consumption, minimum external components, and very easy to use. Okay, motion sensing. Typical motion sensor are Hall effect sensor. TI have all the Hall effect sensor that we have to use with a magnet to sense the motion. So besides the Hall sensor, we also have inductive sensing. This is new to the market where we don't need to use the magnet. Right? We can use the metal detections. Right? When the metal coming close to our sensor, we can detect the distance. And our sensor, very low cost. The sensor could be a PCB coil or a chip coil, very simple to use, or even a spring. Right? For example, right, when you compress a spring, we can also measure the difference. So for example, it could be a pressure sensor, it could be used in the gear counting in the voltmeter. And cap sensing. Today I also heard about a lot of inquiry about the proximity sensing, for example, ring sensor, right? So the cap sensing is also used in ring detection for the automotive, right? On the slow detection in the automotive area as a kind of proximity sensing. And we can also use it as kind of liquid sensing. We could use it to test the liquid level. Give you one example, right? This morning, right, you say that you turn on the coffee machine, right? You can use the handphone to turn on the coffee machine. You can call it a smart coffee machine. But it is not smart enough because you just can turn it on and off. What happens if the coffee machine can tell you, I'm running out of water. How much water I left behind? Or how much coffee you left behind? Right? So you can use this kind of a cap sensing, which is a non-invasive. You don't need to put the sensor into the can. You just next to it, I can sense it. Very high accuracy. So if you want to have more details, so for example, besides the liquid level, I would also like to test the concentration. We also have ultrasonic sensing technologies in TI, right? From a medium distance with a high resolution or to a long distance, like the parking sensor, by 5 meters, 6 meters, we also have, right? Last but not the least, this is the last page. This is the gas sensing, right? Gas sensor available in the market for a long time, but frankly speaking, this industry is a very closed industry. Not much people engaged with it last time because a lot of sensors are based on the quite old technologies using a discrete solution today. Today, here I am introduce you the analog front end. Besides the analog signal conditioning to amplify the signal from the gas sensor, we also provide you a diagnostic functions. For example, there's a lot of sensor all over the place. Do you know it actually working? You don't know, right? If you just install it, I have faith that, oh, this is working because I installed it last month. How about 1 year, 2 years? You don't know, right? So for our new solutions, we can provide a sensor diagnostic program, right? Then you could, for example, fool your handset to question that sensor whether it's useful or not, right? That give you a closed loop. This is IoT. Right? You could go through the car to your home or to the factory to question that sensor, whether that sensor is still workable or not. So we give you a closed loop communication with the sensor, rather than single end communication, just sending a signal from the sensor to the host. Now you could also, from the host, questioning the sensor, whether you are working, you are okay, or you already wear out, you need to change, right? So this is the solution from TI. So in general, we try to give you a simple to use solution at a very low power, very small form factor, and very short development cycle. Right? We try to help you to make your product more competitive in the market because customers change every day, particularly when you're talking about the Industrial 4.0. Right? Industrial 4.0 is talking about from the end customer to the productions. Right? You have to be real-time online. So everything have to be changed according to the customer need. In the traditional method of development, a lot of things you cannot change, right? Because it's too late. A lot of time customer will ask you to change. You will say, sorry, too late. But now with the latest technologies, a lot of things is programmable. A lot of things can be updated over the air. Right? Like all the sensor, all these kind of elements, right? You could control it through the air to change your algorithm at the last minute. Right? Even you ship the product to the customer side, you still can change it. So this is the idea from the Texas Instruments. Thank you.